Hello, I'm Kyle Jones. Today, I'd like to share a little bit about how Amazon Web Services is helping companies use artificial intelligence and machine learning in the utilities and power sector. These are examples of different projects that we've done that are really applying machine learning in order to help companies make better decisions and get the most out of their industrial equipment. Artificial intelligence is a big term, and lots of different projects are related to this. Specifically today, I'd like to talk about machine learning, which is a way of using mathematics to help build models that can replicate some of the human decision making that we might see here. Importantly, it's able to find patterns in data that humans wouldn't be able to otherwise do. And with that information brought to bear, we can then make better decisions. I've helped a lot of companies over the last 15 years on their machine learning journey. And in each of them, there is a standard pattern that I've seen. All projects begin with data. There's an idea of what we want to do and how machine learning can help, but without the data, we can't do anything. So step one in every ML project is getting the right data and making sure we have the right fidelity of the data and that we know what the data means. Once we have that, then we can start to think through where would we apply this model. Sometimes we have a very specific model that can do one thing well, and that's great. Sometimes we have bigger models that make big predictions. There's different ways that we can use it, but we have to be thoughtful about where and when we apply machine learning in order to get the most value from it. Once we have the data and we have an approach, then it's the time to pull the team together. And that's normally a combination of people who understand the statistics and mathematical side of machine learning, as well as subject matter experts who understand what the data means and what makes sense. There's no point in building a machine learning model that is going to violate the laws of physics or not follow the processes that we normally expect. So a common issue we see here is using data that is subsequent to a process to predict the process. That's we need to be looking at data that's an input rather than an output of a process to make that prediction. Those three things are the start of any ML project. In order to really take ML, though, and make it broad throughout an organization, there need to be champions of the ML culture, people who are out there talking about the value of a probabilistic approach instead of a deterministic approach for things like predictive maintenance. That's different than what most engineers are taught going through school. Probabilistic approaches are often thought as the antithesis of what we want to do. We'd like to turn things into deterministic processes. But machine learning gives us some new opportunities within the probabilistic process to help make better decisions. So that's what we're here to explore. And the final step is how do we take models, deploy them, and then get rid of all of the parts that are hard with this? It is fairly easy to make a machine learning model. It's quite difficult to make a machine learning model, put it out at scale, and then maintain it over time. So a lot of those pieces about the difficulty of machine learning can actually be abstracted away using Amazon Web Services. When we think about machine learning, we think about this in three different layers. The bottom layer are the basic frameworks that people would be building upon, like TensorFlow, PyTorch, MXNet. That's where you're going and actually building a raw model. Then you step up from that into an IDE. So for us, SageMaker Studio is our integrated development environment that provides a Jupyter notebook type experience along with a lot of other value for being able to track models and monitor their performance over time. So this is where we expect most people to be spending their time when building on AWS for machine learning. It was within SageMaker. The top layer is AI services. So this abstracts even more away on a problem, and it allows people to use just an API call to make an inference. For example, on Amazon Lookout for Equipment, which is in the center, that is an anomaly detection service. So it already has pre-trained machine learning models in it. And what a customer does is pass the data to Lookout for Equipment, which will analyze it against the pre-known models and then provide a result, which is either that the data is as expected or is anomalous. So it's a binary classification problem that is being done automatically. No model training required. That means that any developer can take that API and embed it into an application without having to build something from scratch. And so that's what the whole top on AI services is about. How do we make this simple and remove that undifferentiated heavy lifting so that people can get the benefit of machine learning without having to build everything from scratch? And we've seen this manifest in a number of ways. One of the areas that we're passionate about is in sustainability and the environment. We're interested in reducing the carbon emissions associated with our own operations, including how do we look at the emissions associated with gas turbines, monitor those, and then improve the efficiency of those turbines so that we can reduce the overall emissions, life cycle emissions of that turbine. For wind turbines, we're looking at how do you get the most power out of these deployed assets. A lot of that comes down to optimizing yaw. And so building machine learning models that can optimize yaw and decide where the best place is given the prevailing winds to get the most power output from that machine. That also starts to look into some high performance computing and being able to do some numerical weather prediction so that you can pre-position these turbines to be facing the optimal direction in order to produce that power. And a final step here is using edge equipment to actually do processing that can help reduce inspection time so that we have increased time to value. And this is about being able to do inspections more effectively with the data available and then make better decisions more quickly with that data. Let's look a little bit more into yaw. This picture shows an actual wind wake that we have modeled before using computational fluid dynamics, but now we see it in real life. And we see how the initial turbines create wakes that propagate throughout the system. Those wakes affect the efficiency of the subsequent turbines. So using data, we can start to look at what would the optimal yaw for the subsequent turbines be, and then even how do we design a field in the future that is going to take advantage of those wind wakes in order to increase power production. An example of one company that is using AWS and wind turbines to help reduce unplanned downtime is DTEK. DTEK is a power producer in Ukraine, and they have deployed AWS services across their fleet of solar, wind, and thermal assets. Their goal is to take SAP data that is part of their ERP and combine that with telemetry data in order to reduce unplanned downtime, which they've done quite successfully, being able to integrate those two things so you have the raw data that shows the telemetry plus the contextual data from SAP, and together they can make a decision about how to run these assets optimally or how to reduce the unplanned downtime based on planned interventions. And another example is a company called Greenco. Greenco they have 7.5 gigawatts of capacity in India, and they are ingesting real-time telemetry data from over 1,200 wind turbines in their fleet and processing that in real time using real-time dashboards to identify the overall health of their fleet and then make decisions about how to best use their mix of different production assets to produce the most power and also to maintain the health of these equipment. So two examples of real customers that are using AWS AI and ML solutions in order to optimize their operations. I hope that this has given you an overview of some of the ways that AWS can use AI ML to help different companies produce more power more effectively. And I look forward to talking more about the role that AI and ML plays in improving your operations.